Hi, it's Mr. Kane here, and we're going to talk a little bit about water and the planet Earth this time. And there's one of my favourite pictures of our planet, taken by the astronauts as they orbited the moon. Shows our planet, the blue ball out there in space, and it is like a spaceship itself. Once you've launched it, there's really no sort of adding stuff to it, or, oh, I forgot something, and pop down the supermarket and get it. So it is with our planet. If we run out of something, there's nowhere else to go and get it. So we've got to sort of look after it, clean it, recycle it, reuse it, because there's no interstellar pack and save to go and pop down to and get what you need to get. So it's a spaceship out there. So we've got one planet for us all 7 point however many billion we have at the moment and growing. But there's a big problem. 2/3 of our planet's oceans, we can't live there. We go out in boats and mess around and fish and stuff like that, but we can't actually live out there ourselves. You know, cruise liners don't count. They still come into port. You know, we can't live out in the oceans. Of what's left over, the third, the land, 1/3 of that third's too cold or it's too high. We can't live there. And 1/3 is too hot or dry. It's deserts. So that leaves 1/3 of a third where we do everything. We live, eat, breed, get rid of our waste, grow our food, everything on that 1/3 that's left over. So we've got to look after it. Looks like this. If this giant rectangle is the whole of the planet, that's the oceans. That's the part that's mountains and too cold or high to live. That's too hot or dry, can't go there. That's the bit that's left for us. Nothing else. And here's a stitched together satellite photo compilation of the planet as if it's night time everywhere and there's no clouds anywhere, and you can see by the lights where we live, and you can see where there's no lights, either they've got no electricity or it's places we can't live. So like for example, down the whoops, go back. Sorry about that. Down the bottom down here, that's all ice, too cold. Same up here, too cold. You know, Greenland, Northern Canada, Russia, too cold. What else we got? Oh, we got the Sahara Desert, too hot and dry. Inside Australia, too hot and dry. Here's a big region of mountains, very high. People do live there. I've been to the Himalayas up through here, but not lots of people live there. Amazon Basin, not many there. Interior of Africa, probably no electricity, the people are living there, but the bulk of the places where people live, it's too hot, or too cold, or too high, or too dry. The lights show the story of where we live. So we're going to look at it again. And we're going to look at what we see the most of. Okay, here's some hints. Some people, you know, I've heard it called Elam's Ale, Gänsewein, my German friends often nickname it. Okay, it can be solid, liquid or gas, yeah. Hopefully by now you've got what it is. Should have it by now. There's that same picture, but basically in daytime. And what we're looking at the most of is that blue stuff. Okay, water pretty much almost everywhere. So that's what we're going to focus on in this little video, is the water. It's what we've got the most of here. Okay, but exactly how much is there out there? How much water do we have? Well, some clever people, there's a credit coming up soon, I'll show where the photo came from, have put together this graphic that shows all the water on the whole planet rolled up, put into a ball and parked over the North American continent. Okay, so it would be about 1,300 kilometres, nearly 1,400 kilometres in diameter. Okay, here in New Zealand, that's about the distance from Invercargill to Palmerston North. That's it. That's all the water we have on the planet. Everything. Okay, all the frozen stuff, everything. And that's thanks to these people here, Woods Hole people, who put this together. Right, water. Where did it come from? As I said before, we're pretty much a closed system, a spaceship. Nothing really much arrives, nothing leaves, really. there's little bits and pieces we can fire into space and we get a few meteorites, but in the big scheme of things, it's hardly anything. So the water that has been here millions of years ago, it's still here. It's the same water. Okay? So the water we drank today was more than likely used by something else before us. Dinosaur gives a baby a bath, more likely the dinosaur drank it and then peed it out. So what they pee out, the water, it's still there and we're still using it. So luckily we've got this thing called the water cycle that recycles and cleans the water, and that's what we're going to look at some more. Okay, so all the water on the earth, okay, this top sort of pie chart, okay, top pie chart, that is all the water on the planet, the whole lot. This little bit here, this little 1% slice, if we expand that out and turn to this pie chart, that's the water we can use. 1% of all the water on the planet. But look at this, groundwater. You can't drink groundwater, you got to it's stuck in the ground. Can't get it. So 1% roughly of the 1% is water that we can get out of lakes and rivers to drink. Okay? That's it. Okay? Only 1% of all the water on the planet is in the form that we can use, and only 1% of that is stuff we can get hold of easily. So another look at that in a slightly different way. So left-hand column, all the water on the planet. Up the top here, okay, that's the freshwater bit. So I take the freshwater part and we expand it into this whole column here. Okay, most of it's frozen. That's underground. This is the stuff here that's on the surface that we can get hold of, a bit over 1% of this little bit here. So it's a couple percent in that diagram, but still not very much, and hardly anything of not very much. So let's expand this one here out into this whole column here, and look at that, over 70% of that's frozen, snow and ice up in the mountains. 20% is in lakes, and then we've got water in the atmosphere. Can't use that, can't drink that. Biological water, can't drink that. Soil moisture, no, can't drink that. Swamps and marshes, most people don't want to drink that. So that leaves rivers and lakes. So we've got, what's that add up to? About 20.5% of the 1% of the 2 and a bit percent. So hardly anything of the water on the planet is in a form that we can simply go put a cup into and scoop up and drink. So we've got to look after it. That looks like this. So here's that diagram again, but now we've got the big bubble, that's all the water, all the fresh water, but right there, that little pixel there, that's the lakes and rivers. That's the stuff that we can get hold of, put a cup into and drink. Okay, but think of your nearest river, your nearest stream, lake or pond. What's the closest one? Okay, would you go and drink out of it? Okay, if you're thinking, ooh, no, I'm going to drink that, what are you doing about it? That's the water that we've got to drink, the stuff you can dip a cup into. That's the stuff we need to make sure we can drink, we can swim in. What are you going to do about it? You should be able to go and just drink the water. So, if the water's always been here, how is it clean for us to drink? Because we haven't always had treatment plants and rivers in cities and towns. How does the planet clean our water? The water cycle. Okay, let's have a look at that. So, here it comes. The water cycle. Okay, so this is the water going round and round. You can see the arrows going round. Okay, the most of it's in the oceans. Okay, so then we've got key things. Evaporation, condensation into clouds, and then it rains on the mountains. That's the guts of it. The moment water evaporates, all the bad stuff gets left behind. Only water gets evaporated. Pure water then comes down as rain once it's condensed into clouds. That's how it gets cleaned. Okay, and then we get stuff running off down rivers, and it soaks through the ground as well. And that also helps clean it. Here in Canterbury we've got big aquifers under the ground, and that helps filter the water. Okay, simpler version. Evaporation. Okay, over here we're at evaporation, condensation, precipitation. That's the guts of the water cycle. Precipitation brings it down somewhere. Evaporation makes it go up into the atmosphere again. So this is all coming down. And condensation is when it turns into clouds and the wind blows it wherever it's going to blow it. And round we go. The water cycle, around and around. Now, this is a key thing. We don't actually own the planet. We're just living here for a short while. Okay? We didn't inherit it. I really like this. We're borrowing it from the next generations that are come after us. What are we going to give them? A nice place to live, or a place that's completely messed up? Because that's what we're doing. We're not looking after it very well. Okay, that's it for the water cycle. And next time I have a drink of water, think about where it's come from, where it's going, and how it's going to be cleaned.